let's look at another example of basic combinations of functions. So now we have two other functions. Given the functions f of x is equal to x squared minus 9 and g of x is equal to the square root of x minus 2, find the following and state the domain. All right, this first one is asking us to find f times g of x. Well, what does that mean? We are taking f of x and we are multiplying by g of x, our function x squared minus 9 times the square root of x minus 2. In terms of simplification here, okay, not much is going to simplify, right? Our final answer is the quantity x squared minus 9 times the square root of x minus 2. There is no distributing that we can do here because all of these quantities, the x minus 2, are grouped inside of the radical, and we can't multiply into radicals. That's our final answer. All right, now let's talk about the domain. So for our domain, we need to look at the domains of the individual functions and the domain of our combination as a whole. Well, we have no restrictions on f of x. There's nothing that we have to worry about there, okay? However, we do have to worry about the domain of g of x. So the domain of the product of f and g must be the intersection of both domains. As we said, for f of x, no restrictions. Our domain is going to be all real numbers. Well, what about our function g of x? This one has a square root. So what do we have to remember? The quantity inside of the square root must be greater than or equal to 0. So let's set up that expression. What's inside of the square root? X minus 2. What has to be true about it? It has to be greater than or equal to 0. Once we set up this inequality, solving the inequality will give us the domain. X is greater than or equal to 2. Written in interval notation, this would be bracket 2 comma infinity. So the domain of our combination, the product of f and g, is going to be where these two domains overlap. Well, where do these two domains overlap? They overlap on the interval from 2, included 2, to infinity. That is going to be my domain of my combination, f times g of x. All right, let's look at this one. G divided by f of x. Well, that means we take the function g of x and we divide by the function f of x. That is going to be the square root of x minus 2 divided by x squared minus 9. So a couple things that we're going to have to worry about here. All right, again, no algebraic simplification. Nothing is going to simplify here. That's just our final answer. The domain of our quotient of g and f must be the intersections of both domains, and also it must be true that the denominator does not equal 0. So, as we've done already, we took a look at the domain of f of x. We said the domain of f of x was all real numbers. Then we looked at the domain of g of x. Well, the domain of g of x, we said that the quantity inside the radical had to be greater than or equal to 0, so we had x was greater than or equal to 2. Finally, we also have to look at the domain of our combination as a whole. What else do we have to worry about here? Well, the denominator cannot be 0. Let's set up that expression. X squared minus 9 cannot equal 0. Let's solve for x now. Well, let's add 9. That gives me x squared cannot equal 9. And taking the square root of both sides of that equation tells me that x cannot equal positive or negative 3. So what this means is that the domain of my combination, root x minus 2 divided by x squared minus 9, has to be where all three of these domains intersect. All right, where do all three of these domains intersect? Well, automatically going to be limited to values that are greater than or equal to 2. And notice that as I move to the right of 2, I'm going to hit positive 3 where I can't equal positive 3. And then anything beyond 3 is going to work out. Therefore, we have our domain is bracket 2, comma 3. Again, we can't equal 3. In union with 3 to infinity. I don't have to worry about the -3 really in this case because the domain for g of x already gets rid of the possibility of x equaling -3. So our domain for our combination of this quotient is going to be the overlap of all three of our domains, the domain of f of x, the domain of g of x, and the domain of the combination as a whole. Okay, that's how we get the domain of our combination g over f. All right, same functions. Now let's just flip it. F divided by g of x. That's f of x divided by g of x. X squared minus 9 divided by the square root of x minus 2. Again, no algebra to simplify there. That's just our final answer. There is our quotient f of x divided by g of x. Now we have to look at the domain. And as we said, we need to look at the domain of the functions individually, and we need to look at the domain of our combination as a whole. So, the domain of our numerator, all real numbers. There are no restrictions yet. What about the domain of g of x? Well, as we said, the value inside of the even root must be greater than or equal to 0. So x must be greater than or equal to 2. There's my domain for g of x. Now, two rules are going to come into place here. One is the denominator cannot not equal 0. And also make note, we still have that restriction for the combination where this quantity x minus 2 has to be greater than 0. So this one is still applying. And we also know that the square root of x minus 2 cannot equal 0. Again, the denominator cannot equal 0. So let's see if we can't solve for x. To solve for x, we would square both sides of the equation. Squaring is the inverse operation of taking a square root. It undoes that square root. That gives me x minus 2 cannot equal 0. In solving for x, I get x cannot equal 2. So the domain of my combination, that's x squared minus 9 divided by the square root of x minus 2, has to be the overlap of all three of these domains. Well, where do all three of these domains overlap? That's going to be values that are greater than 2. Our domain here is going to be from 2 to infinity.